So we're going to jump straight into our next presenter. Next presenter is Silvia Hagen, who's the CEO of Sunny Connections. Silvia flew all the way out from Switzerland, 26 hours, you said? 26 hours to join us. So make sure you pay attention because she took time to come out and visit us. She also happens to be the author for the O'Reilly Press Planning IPv6 and also for IPv6 Essentials. Is that correct? Yes. So let's welcome Silvia.
Well, thank you, Ed, for the introduction, and hello, everybody. So I haven't been traveling today, right? So I had some hours of sleep before standing here in front of you. So we'd like to spend the next half hour with the presentation on enterprise adoption planning, and we have already heard a few presentations. The perspective I'd like to take in this time with you is like the experiences we did with consultings in large enterprises over the last 2-3 years. And they have been large enterprises with headquarters in Europe, mainly Germany, some banks in Switzerland, but also companies over here in the United States. So as like the main topic of this conference and the keynote address, they were talking about a holistic approach. And as you are going to see, our recommendations on what enterprises should be considering when doing IPv6 planning, they sort of align with this. Now the problem is that it's very difficult in a large enterprise to do something holistic because they're all fragmented. So let me go a little more into this. The topics that I'd like to cover today is a short picture on the evolution of the internet. This is probably a note which goes more to the people that some still exist that think IPv6 has no business case. And so I need to take that up in case you have to discuss with somebody that has this opinion. Then the IPv6 101 is just to show, where do we need a lot of time and education to go into the details before we are capable of doing new future-oriented concepts. Then we see if there is a killer app for IPv6, because actually I think there is one, and a very important one. And the second part of the presentations is on the steps that we usually go through when enterprises are planning. So, the evolution of the internet started, we could say, more probably in '69 when RFC number 1 was written. So it's been a long time. It's been like almost 40 years. And we can say that the internet is like a global corporation. And the internet sort of happened because we all jumped on the wagon. And that wasn't in the 70s, it wasn't in the 80s. We can say that the internet, as we know it today, sort of started to develop in the second part of the 90s, right? When people really started to use it. So we can say that we all together created the internet, and the internet grows exponentially, and it, from today on, because the IPv4 pool is empty, it cannot continue to grow with IPv4. It can only continue to grow with IPv6. So those of you who are familiar with the IPv4 IANA pool exhaustion numbers, they know that the consummation rate has more than doubled in 2010, which led to the fact that the pool was empty even in February 2011. In 2012, we celebrated the World IPv6 Launch Day, which has been mentioned a couple of times today. And in December of this year, we are going to celebrate the end of the Mayan calendar. And I kept saying that the Mayans probably just made an IPv4 calendar. That's why it ends in 2012. So what we're actually doing when we introduce IPv6 is we are launching the second generation of the internet. Because all the future services and all the future expansion of the internet is only possible over IPv6. So this shows the depletion of the IANA pool. To say it very generally, we can say that in the last 10 years we have used plus minus 10/8 per year. And we started January 2010 with 24/8 left in the IANA pool. And just 1 year later the pool was empty, even though 24/8 should have been sufficient for another like 2 years. So that shows that the rate was more than doubled, and that was the consummation rate. So that's also the rate that shows how the internet is expanding. So if you look at this summary of the growth of the internet, when in 2001 we had approximately 350 million people in the internet, Only 4 years later, we had almost 1 billion, and in 2009 it was 1.4, and in 2012 now we're up to approximately 2.3 billion. So if we do an extrapolation of this, and we're very careful and conservative, we can assume that by 2015 we may have something like 5 billion, or maybe even a lot more users in the internet. I hear some voices, they say, oh, we'll have 3 billion mobile devices in the very near future. Now, the big difference is that because the IANA pool and the IPv4 pools in some regions are empty already, is that the difference from today to then, like 3 billion or even more users, will be IPv6 only users with very good native IPv6 performance, but natted or translated IPv4 performance. So, it's not the end of the internet, it's the IPv4 internet is just stopping to grow, and it will grow over IPv6 in the future. So as I said, and that's one of the things that customers have to be aware of, is that the future users which are coming to the internet, they have native IPv6 connections and in many cases translated IPv4 connections. So that means they probably don't have such a good performance over IPv4, or if you offer a complex service, maybe an e-commerce site or online banking, you may, or a voting site like governments, you may have bad performance or you may even have a broken service. So if you offer content on the internet and you want your site to be reachable by everyone with the best possible performance, the only way to achieve that is to, from today on, offer your public services dual stack. And also another reason to go IPv6 with your public services is that your analytics only work if you have dual stack IPv6, because all those users that come from behind multiple layers of NAT, you cannot identify them anymore. So, IPv6 is inevitable. We have no choice because the global pool is empty and there are no alternatives to IPv6. So, for those people that still think they need a better business case, we can say the main business case is your business continuity. And if you want to have a cost-efficient and lean integration in your larger enterprise, you need a lot of time for planning, and you also need to plan ahead because you want to make use of your product life cycles and refresh cycles, because that is where you can save the most of money. And the third reason to really take your time for careful planning is that you want to use the opportunities that IPv6 offers. So, when you do early planning, this allows for making use of your product life cycles and refresh cycles, and it gives you investment protection because based on your design you can have clear requirements for RFCs whenever you buy new products, whenever you sign outsourcing contracts or SLAs. And you have risk mitigation by securing unwanted IPv6 traffic. I think this has been discussed before, right? Even companies that think we don't do IPv6, they need to they secure their border from IPv6 traffic because most operating systems have IPv6 enabled by default, which can be used for security attacks. So, and then the most important thing is the second bullet, it's the education of all IPv6 team members. Is if you want to do nice concepts, if you want to use the opportunities that IPv6 offers, then you need to educate your people quite ahead. Because IPv6 has a lot more features than IPv4 used to have. So we have to get rid of our IPv4 mindset, and we have to first take our time to understand the architecture of IPv6, and then we have to free our minds from the IPv4 thinking and make sure that we create new concepts which make use of the advanced options. And we also need sufficient time for labs, testing, and pilots before we finally deploy. So, I mean, I think that you don't need really IPv6 101. This is like one slide that shows the main differences of IPv6 over IPv4. And the blue ones are the ones where you really need to take your time before you start building concepts. So the IPv6 address space is more than just an expansion from 32 bits to 128 bits. It's a lot more than that. So before you can actually create an IPv6 addressing plan which will support your business and be okay to operate, you need to understand the address architecture. So it's not a good idea to copy your IPv4 address plan to IPv6, because that, if you do that, I mean, you would get it to work somehow, but it would be a straitjacket for the future of your network. So you don't want to do this. And also the extension header architecture requires some thinking. And in combination with the addressing capabilities, you also can consider to build new security concepts, and we'll come to this. So another option that I find with some customers that we've been working with, some customers, they develop applications to sell on the market. Other customers have a large set of homegrown applications that they use internally for their business services. And they are usually absolutely not aware of the implications of IPv6. So whenever you have high investments in applications or services that you deliver to whoever it is, you have to become aware of what IPv6 means to developing these applications. And you should be making sure that these applications work in an IPv4 environment, in an IPv6 environment, and also in a dual stack environment. So when we come to the planning section, we have like 5 major steps that we go through with the customers. And when it comes to really large enterprises, I would say that we usually work with the first, the second, and the third option here. So most very large enterprises, they are today in the planning process. And because it should be holistic, and everybody in the enterprise, all different groups should be integrated into the project and be part of the project team, it takes a long time. So sometimes if in a large enterprise we ask, for the duration of process, like how long does it take until you have selected a new device type or a new vendor and are ready to, choose a model and then implement it. So we very often hear time frames of 5 to 8 years. So you better get started and make sure that at least you got your purchasing guidelines ready pretty soon, so that from today on or from tomorrow on, you can start buying the right equipment that will support your long-term plans for your network. So in the first step of the project that we call discovery is that we usually do a layout of the current landscape. So we look at everything, and we start with the vision for the enterprise, because IT should actually be a supporting service to do the business, right, in most cases. So we look at the business strategy. We also look at the IT strategy, which is something that is protocol IPv6 independent. It's the strategy for the IT in general. We look at the landscape, the current state, we look at processes, we look at what other IT projects are lined up for the future, we look at product life cycles, and we try to define a future state for infrastructure and services. So we ask, where does the enterprise want to go in the business sense and with the IT? And so based on all of this information, we can do an impact analysis. So we describe the risks and the opportunities that the organization gets, and then we define a high-level plan. So we define on where do we want to be with our networks in 5 to 8 years, and once we know where the goal is, we take all the other information we got about IT projects and life cycles, and this helps to now define a roadmap. How do we best get there? And that is the main reason why you cannot say, oh, there is this simple approach, this is how you can do it, here's the cookbook, go for the IPv6 integration. It's different in every enterprise, because you try to do it the leanest way. So depending on what other things are coming up, you will choose a different path to get where you want to go. So in the strategy phase also, you can identify dependencies and align all these different processes and projects. Now, once you know your target architecture and your roadmap, you are in the position where you can define your RFC requirements for all different types of network devices in your network. So this has to be, there are the templates that you find out there, like USGV, and in Europe it's the RIPE 554. But that's like a good, very general starting base. Now you want to take these profiles and adapt them to your specific individual design that you have chosen for your future network. And so now you can update your purchasing policies, you can update your outsourcing contracts and SLAs, and you can start an assessment of your current environment. And because this is a time-consuming task, you try to make this as soon as possible. Only after you have gone through such an assessment of your infrastructure and services, You can now refine your high-level plan. Maybe you create some corrections to it based on the findings that you've done. And you can update your requirements, and at this point you can like identify the costs that will be associated with the introduction. So before your assessment, you can have a very general idea, or you can use Gartner's estimate that says like it's going to cost you 6% of your overall annual IT budget. But after you've done an assessment, you have a much clearer picture on how much will you have to invest in applications and hardware, and how much labor is going to be involved with doing the steps. And obviously these costs, they will probably go over a period of maybe 2 or 3 years, or in some cases even longer than that. So, and then the main 2 recommendations is, before you go through these steps, you do a lot of education. So the people that work on the IPv6 project from within the company, they should have a lot of education. They should have the opportunity to play around with IPv6 in the lab and to get their first experiences before they start assigning projects. So, things to note as a summary: the biggest risk is to not take full advantage of the IPv6 transition, which means do your education first, learn about the new architecture of the protocol, and then use all the opportunities. So the success of the project depends on a complete view, or aligned with the topic of this conference, it depends on a holistic view. It's an effort across teams and projects, and that's one of the factors that creates the largest challenges in an enterprise. It's how do you get people on the table that usually don't talk to each other. And you need a project manager or a project office, an IPv6 transition office, as we like to call it, that can coordinate all the activities across the whole enterprise, so like across all different departments. So, and again, we can't say it enough, make sure that your project members have enough education before they start working on the concept. And the last bullet is an important one. In most enterprises, when we ask them to sort of give us a picture of their landscape, they show us their address structure, they show us their routing infrastructure, they show us their security concepts and their zone concepts, and they have a lot of things that they don't like anymore, because this has all been historically growing. So some of the customers say like, oh, you see, this is how our security concept works today, but actually this is way too complex. We wish we could make it a lot simpler, but it's not doable. We have been thinking about this a couple of times, it's not doable, but now you can do it. You don't have to do it in IPv4, but you can redesign your network by introducing IPv6. So you can do all the clean out in your new concepts that you do for IPv6. So that's one of your biggest opportunities. It's like when you're moving, right? You have a chance to throw away all that old stuff you don't need anymore. So this is a summary of the Gartner perspective. As I said, Gartner estimates in a newer report, 6% of the annual IT budget will be your average cost for IPv6 transition. And once the migration is complete, the ongoing costs will come to about 1% of the IT budget. So, and Gartner says that you should have IPv6 capability on the internet within 2012 to 2015. And I would say you'd rather want the 2012 than the 2015, probably. So general design rules, you have heard some presentations today about core to edge and edge to core. I don't want to go too much into these details. I just summarize our most important rules that we use when designing. So native IPv6 wherever possible, dual stack as long as necessary. And in the enterprise internal network, we say new services, try to roll them out IPv6 only as soon as possible, which means try to go to a dual stack backbone infrastructure as soon as you can with dual stack clients, and then you have the opportunity that if you have new projects and roll out a new service like next year or the year after, that you can deploy the service IPv6 only right from the beginning. Why should you go through all the work to make it work on IPv4 knowing that you will have to migrate it to IPv6 soon anyway? So if you can, if there is a possibility, you will try to use this option. Tunnel only if necessary, only as a temporary solution. No NAT, no translation, as we've heard before, only with a gun to your head, and there may be some cases where you can't get around it. Future networks are end-to-end, and then the security. So expanded address concept allows for new security concepts, like use more service information within the address, which you can then use in your security concept. And when it comes to security, I must say this is the area where you probably need most of the time, because the security people, they are very often really scared from IPv6, because it requires them to rethink everything they have been doing for the last couple of years. So that means you have to give them a lot of time for thorough education on IPv6 security specifically, and you need to take a lot of time to redesign those concepts with them. Otherwise, they will just end up trying to copy from IPv4 what they're so used with. So this will take a lot of time, so make sure you prepare for this. And then whenever you build new concepts and address designs, also you have to create a lot of space for growth. And you don't only need, to consider growth the way we've done it in the last couple of years, but you have also to consider all those new types of services that are coming up, that are developed in all industries, which will take up a lot more address space than we're used to. So all these monitoring and sensor devices, in healthcare, for instance, where infusion pumps and intensive care stations have, I don't know how many hundred IP addresses, maybe car-to-car communication. So I think in every industry you will find these services. So go and look for it, depending on where you are working, and see what the future may be bringing. And make sure you assign that address space to do it. Assessment, as I said, it will take some time. So you have your RFC requirements based on your design, and now you have to go through every device in your network and through all the applications, see which systems are IPv6 ready, see which systems need to be upgraded for IPv6, and which systems will not be IPv6 ready, and for these you may have to look for a replacement. You also assess your vendors, and as we have heard before today, you may even choose to replace some vendors with your plans for IPv6. Address plan, you use all the rules that you know from building an IPv4 address plan, but you have to get rid of everything you did in your IPv4 address plan that had the purpose of saving addresses. You don't need to save addresses anymore. So you have to value ease of administration over conserving address space. Means if you have different outside locations, just assign the same / whatever to all those sites, because it makes your administration and your security concept a lot simpler. And is reserve enough space for growth. So as a summary, the 7 most important steps. The first step is very important. You have to get management on board. If you start IPv6 as like an infrastructure project, you may get to a certain point, but you cannot really complete a project with the holistic perspective that it requires. You can only do that if you have full support from management. Then step number 2, education for all team members, focused and specific to groups. So everybody needs a general IPv6 introduction, and then the different teams need in-depth education in the areas they're working in. Then you define the strategy, the high-level plan, and the roadmap for IPv6. You perform assessments, hardware, software, operating systems, services, and apps. You may refine your strategy after that, and you may refine your roadmap depending on the assessment results. You can now create your budget for investments and work over the next couple of years. You can define your address plan and your network design and your security and management concept. And during the whole process, you should start setting up labs for your people right from the beginning. Give them labs so they can play with it, they can test everything, especially also create labs for the application people, because they need most time for the testing, so they should get started with it. The most common stumbling blocks, it's lack of management support, it's heads in the sand politics, a very common thing. It's processes in large enterprises. Sometimes it's almost impossible how long some processes can take. One more reason to start as early as possible. It's short-term thinking. If you think in like 3 to 6 month terms, an introduction of IPv6 never makes sense. But I think we need our networks, right? If you ask these people if they were ready to turn down their networks, they're probably not. It's lack of authority within the organization, so that's the effort why you need an IPv6 transition office, so you get everybody across teams and departments to talk to each other and to plan together. And it's just a general work overload. Most of the people that I work with at customers, they just have too many projects on their plate. Less people, layoffs, less people have to run more projects. So there is an end to this. And the last bullet, treat IPv6 as a network and infrastructure project. It will not work in the long term. So this is the summary. IPv6 is on its way. It will take you 3 to 5 years at least for a smooth and cost-efficient migration. So start today. Why now? Summary of the reasons. Number 1, business continuity, reachability from outside, lifecycle management, investment protection, and enough time for education and to build experience so you can take advantage of all the opportunities IPv6 offers. So that was it. Thank you very much for your attention, and I wish you fun with the conference.